y is less than or equal to 1/2 x minus 3 starts at the y-intercept of -3 and continues up 1/2 all the way across the graph. It's going to have a solid line because of that or equal to. And because of the less than, we're going to have to shade it down. I just need to move this out of my way. So we're shading below the line. For y is greater than or equal to -3x plus 4, we start at +4, and we're going to go down 3 and to the right 1 all the way across the graph. And again, it's solid because we still have an or equal to. This one is y is greater than, so I'm going to change my colors, and I'm going to shade above. We always want to make sure that we label the point of intersection. So I would label the point to -2. It happens to be labeled over the green region, which is the actual solution region. And I'm just being careful that I label dark enough that you can see the labeling right through the shaded region. And then I also need to label one more point in each line, so I'll just choose the y-intercepts because they're probably the easiest ones to pick. Oops, I lost my line. There we go. And just to make the final regions a little bit more clear, I'm going to go in, I'm going to erase the regions that are not part of the solution and leave only the overlapping region. So that's what it looks like when only the overlapping region is shown. Every point inside that green region is part of the solution. In number 2, we have one kind of nice and straightforward, y equals mx plus b. We've got a slope of -3, and we're starting at the origin. So we're going down 3/1 from the origin and up 3 back 1 from the origin. This time it's a dashed line because there's no or equal to. The other one, it sometimes is a little bit easier if you flip it around and think of it as -x plus 2. It makes it a little easier to see what's going on. So for that one, I'm going to go to +2, and I'm going to go down 1/1. That one's also a dashed line because it also doesn't have an or equal to. So I can see that they intersect here at -1, 3. I haven't done any of my shading, but I'm going to finish labeling first. So one of them started at a y-intercept of 0, 2. The other one started at 0, 0, so I'm fully labeled. And let's look at the shading. So if I shade the first one, I can see that it's y is greater than. So the steep line, I need to shade everything above. And then for the not as steep line, it says y is less than, so I would be shading everything below. When I do that, I can see that the overlapping region is down here in the bottom right-hand corner. So I'm going to go ahead and give my solution again that shows just that final shaded region. There we go. That's the graph of just the solutions. Let's look at number 3. Number 3 is a vertical and a horizontal line. Remember, y is less than 3 is a horizontal line where all the y values are equal to 3. I'm making it dashed because it's less than only. And so that means I'm going to shade everything below this line. I'm going to shade kind of rough because I know that I'm going to go in at the end and take out everything that's not in common. X is greater than or equal to -4 goes through a vertical line. This one's solid because it does have the or equal to. It's vertical because this is where all the x values are equal to -4. Now, this tells me to shade greater than, and when we have an x alone, that's the only time that I think left or right. Left and right, I go to the right when I have x's that are bigger. So I can see this bottom right-hand quadrant is the part where I have my overlapping region. So I'm going to give my solution there only. I am going to need to go in and label the intersection and then one more point on each of the lines. So I'll do that as soon as I get the shading in. So personally, I would pick the y-intercept, the x-intercept, and their intersection as the 3 points I would label. In number 4, we have 2 y equals mx plus b, and right away I notice that they have the same slopes. So I know that the lines are going to be parallel. So I'm either going to have a strip in between the 2 parallel lines, which is my solution, or they're going to shade away from each other and I'm going to have no solution. But I don't know until I get in there and actually make the graph. So I'm going to the y-intercept of 1 and then up 3 over 1. It's a dashed line. And then I'm going to negative 2 and also going up 3 over 1. This one's a solid line. Now, from the solid line, it says that y is greater than. So I would shade everything above that solid line. And then from the dashed line, it says y is less than. So I would shade everything below the dashed line, and I can see that I'm getting green in between the 2 lines. So that's where my final solution actually is. My final solution is the little strip right in between those 2 lines. So there are infinitely many solutions, but they're in this little narrow band. I do need to label 4 points because they don't share any points. So I've got to get my 2 points per line without any benefit of something counting twice. Flipping the paper, let's take a look at number 5. So I've got an absolute value here. So I can see that it's going to open up from negative 1, negative 3, and it's going to have a slope of plus or minus 2. I can see that it's going to be solid because there is an or equal to. And that we're going to shade above. So I'm shading above this absolute value. The standard form needs to be solved for y. So we're going to subtract x from each side. So we have y is less than negative x plus 2. So I go to my y-intercept of 2, and I go down 1 over 1. And this one's dashed. Now that's a little bit tricky. I can't actually see the intersection here on the graph, but I imagine extending that. This is going to go up, they're both going to go up through that next point. So I'm going to go ahead and extend it further. That would intersect at negative 7, positive 9. They also intersect at 1, 1. So that gives me the 2 points for the line. Now if I look at the shading on the line, I'm supposed to shade below. So that would be down here. So those are in common in this funny little triangular area there. So that's what I'm going to give my shading to. I can get a lot of it shaded with this thick highlighter, but I'm going to have to go in with something a little bit more narrow. To really be precise. All right, I need to label my vertex at negative 1, negative 3. And I need another point up each side. So let's go with 3, 5, and maybe negative 4, 3. And that gives me enough labeled on each thing that's required. Number 6, we have 2 standard form inequalities. So I have to solve each of them for y. So if I have 3x plus y is greater than 6, and I subtract 3x from each side, I have y is greater than negative 3x plus 6. So I'm going to go to positive 6, and my slope goes down 3 and to the right 1 each time. It's a dashed line. And we would be shading above this line. So everything in here would get shaded. If I have x plus y is greater than or equal to negative 2, and I subtract x from each side, I have y is greater than or equal to negative x minus 2. So that's going to start at a y-intercept of negative 2 and go down 1 over 1. They just barely do intersect on the grid. This one is solid. And this one says to shade above the solid line, so I would be shading up here. So when I look at where's the overlapping region, I can see that it's this section up at the top. So I'm going to take out all this extra so we can just see the final solution. The final solution will be above both of them. So above the solid and above the dashed. And then, of course, we'll need to go in and make some labels. So we'll want to label their point of intersection, which is at 4, negative 6. And then one more point on each line, so maybe 0, 6 and 0, negative 2. In number 7, we're being asked to do something a little bit different. Here we're being asked to write the inequalities for each of the systems. And given how awesome my penmanship is, I thought maybe I would take a moment and actually type these on here. Oh, but that seems to be having trouble as well. Hold on. Okay, it looks like I'm going to write after all because typing doesn't seem to be working. So if I look at this first solid line coming down here, going through negative 3, negative 4, and 0, negative 6, I can see that it seems to have a slope that goes down 2 and to the right 3. So negative 2/3 is my slope. Let's try to write that a little more clearly. Negative 2/3 x. And I can see that it goes through a y-intercept of negative 6. And I can see that the shading is above the line and that the line is solid. For the other line in this pair, I can see that the line is dashed, but that we're shading above it. So it's still a greater than, but there's no or equal to. Looking at this one, I can see that the slope seems to go up 3 and right 1. So I'm going to see 3x, and then it goes through a y-intercept of positive 5. So that's our system. Next, we've got a set of parallel lines, and it looks like the slope goes down 2 and right 1. So I'm going to have 2 lines that each start with negative 2x. They do have different y-intercepts. The top one is a solid line where we're shading below it, so that's going to be y is less than or equal to, and it's starting from the y-intercept of 3. The bottom one is also solid, but we're shading above it, so I've got y is greater than or equal to, and I can't actually see the y-intercept. So I'm going to switch over to a point slope form. and just pick one of the points on that line. So maybe y minus -4, so plus 4, is greater than or equal to -2 parentheses, x minus -3, so that's plus 3. In the last one, let's deal the absolute value first. We can see that this absolute value opens up and has a slope of 1. We can also see that the shading is above the absolute value. So we've got y is greater than, no or equal to because it's dashed, and then just an absolute value because we don't need to flip it upside down and we don't need to give a slope other than 1. I can see that the x value is 5, so I'm going to have x minus 5 inside the absolute value. And I can see that it is down 3, so I'm going to have a minus 3 on the outside. For the line, I can see that we are shading below the line, and that's dashed, so y is less than. I can see from looking that the slope of the graph is 2, so it's going to be 2x, and it's starting from -7. So there's our y equals mx plus b equation.